and you are welcome to this maths tutorial class. In this class, we are going to cover the topic straight line. On a straight line, you can measure the following: gradients of the straight line, equation of the straight line, parallel and perpendicular line. There are other things you can do on a straight line, such as finding the distance of the straight line, the midpoint of the straight line. However, we are not going to cover that in this very class. What we are going to cover, we are going to focus on gradient of the straight line, the equation of the straight line, and then if two lines are either parallel or perpendicular. Now, this is what we are saying. If this is a straight line PQ, the first coordinate of P is S1, Y1, while that of Q is S2, Y2. So, in order to find the gradient, also known as N, is going to be change in Y over change in X, change in Y over change in X. And what does change in Y means? It means Y2 minus Y1. What does change in X mean? S2 minus S1. That is what we can find above. So gradient of the straight line is Y2 minus Y1 over S2 minus S1. Whereas the equation of the straight line, that is of 2.4, is going to be Y2 minus Y1 over S2 minus S1 equated to Y minus Y1 X minus S1. We also have the slope intercept form, which is Y equals to mx plus c. We might take a look at this as time goes on. However, if two lines are parallel, their gradients are equal. So M1 signifies the gradient of the first one, M2 signifies the gradient of the second one. And if two lines are perpendicular, the product of their gradients is equal to minus 1. We are going to see all this in the example above. We have 3 examples to cover what we have discussed here. The first one, we have to find the gradient of the straight line that is joining the points P and Q. So if we take a look at that, our point P will form S1, Y1, while point Q will form S2, Y2. So picking the gradient now for number 1, M equals to Y2 minus Y1 over S2 minus S1. So what's our Y2 value here? Minus 3. What's our Y1? Minus 7 into bracket minus 7 over what's our S2? Minus 2. And what is our, that's minus, what's our S1? Minus, that's 5. So doing this now, we are going to have minus 3 plus 7 now, that is 4, over minus 2 minus 5, that is minus 7. As you can see, this answer is option C in the question. Let's move on to the second one. Find the equation of the line through the points. This is the first point and the second point. So, in order to do that, in order to do this, the first point will always have S1, then Y1. While the second point is having S2, Y2. Now, if you want to find the equation that goes through this, we are using this formula. So quote the formula: Y2 minus Y1 over S2 minus S1 equals to Y minus Y1 over S minus S1. Take note that our Y1 will always be outside, so don't get them twisted together. So what's our Y2? 4. 4 minus, what is our Y1? 1. What's our S2? 1 minus S1 is 1 as well, equals to Y minus, what's our Y1? 1. And then X minus, what's our S1? That is minus 2. So putting this together now, 4 minus 1 is 3, 1 minus 2. S2 minus S1. Our S2 is 1, our S1 is minus 2. Sorry for that. Minus 2. So 1 minus minus 2 will also give us 3. So having this now equals to Y minus 1 X plus 2. So when you cross multiply, 3 over 3 is just 1. So when you cross multiply, you have Y minus 1 equals to X plus 2. So putting this together, we have y plus x. Then when the 2 comes, that's minus 3 equals to 0. So this is the equation of the 9 for question 2. Let's now move on to the third question. Talking about the third question. Let's solve that here. The third question is focusing on two different lines. The first line passes through these points, while the second line has this equation, and the second line is perpendicular to the first. So for perpendicular lines, we are going to have the product of their gradient to be equal to minus 1. But how are we going to know the gradient of the first one? If you pick this as the first line now, you can easily modify this equation to be in the form of slope-intercept form. So for our M1, you can modify that 4x plus 3y minus 5 is equal to 0. So if we modify it, we are going to have 3y equals to minus 4x plus 5. So when you divide through by 3, you have y is equal to minus 4 over 3x plus 5 over 3. So if you compare it with the equation of slope-intercept form, it's going to be y is equal to mx plus c. So that means this m is the slope of the first line. So we can keep that here. M1 is minus 4 over 3. That's the first one. So that means we are looking for the other slope, which is also known as gradient. Let's see how we can calculate for that. Pick it from this point. So that means the given point of minus 2, 3 is going to represent S1 and Y1. So this, to get the gradient of this, I'm going to get it from the 1.4. So which is M2 now is going to be Y minus Y1, X minus S1. So that means the second gradient is Y minus, what's our Y1? 3. X minus, what's our S1? Minus 2. So if we do this, you can now go with the formula that says M1 times M2 is equal to minus 1. So our M1 is minus 4 over 3. What's our M2? Y minus 3 over X becomes plus now, plus 2 equals to minus 1. So this is the relation that shows that they are perpendicular lines. So if you want to continue this now, you can use this to expand this side and this to also expand this. So let's do that. We're having minus 4y minus 12 is going to be plus now over 3x plus 6 equals to minus 1. So if we cross multiply this now, we can continue it. We're having so if we cross multiply this now, we are going to have minus 3x minus 6 equals to minus 4y plus 12. So we can connect the like times and we're having minus 3x plus 4y minus 6 minus this, that's minus 18 equals to 0. So together now, if you don't want, you can rearrange. You can make it to be 4y minus 3x minus 18 equals to 0. And that will be the equation of these two perpendicular lines. Thank you.